think the recorder is on. Let me just double check before we get started. So the recorder is on. It's recording from the right channel. So let's go ahead and get started. I didn't have enough time to make up the next homework assignment, which is based on archery, and it's using sprites and a canvas. So I want to give you something to start with. I don't want you guys to have to worry about the math of the whole thing. So I still need a little bit more time to get that one up and running, but that's going to be your next homework assignment. It will first involve just shooting at a target, so the target will be stationary, but your arrow doesn't go exactly where you aim it because of gravity, right? There's such a thing called gravity. So it will have a little drop. My code will help you deal with that. Okay, but you will have to do some modifications, give you the instructions of what you need to do. But I'm hoping it will be a kind of like a fun project. The next project is going to be based on archery as well, but this time the target will be moving. Okay, so you're going to write some code to make the target move, okay, and animate the target too. So you would kind of do a funny thing. If the class does not mind, if you have a problem with it, let me know and I can change the nature of the homework assignment. But if you guys don't mind, I can make it even Halloween themed.
Oh wow!
Yeah, so we have jack-o'-lantern rolling around or something like that. But some people may not like that idea. If you do not, let me know. You don't have to.
Bow and arrow with a witch's wand and roll sheet.
Good idea. Let me see if I still have it.
So
I don't have a new one. Yeah, this is a little early. First day of the week too. Yeah, it's not up yet. The homework assignment is not there yet. I just want to give you guys a preview of what your next homework assignment will look like. I'm gonna pass the road sheet in just a little bit. Are there any questions about sprites? At this point.
Not about sprites, but I have a couple questions.
Go ahead.
One, can you rename your project once you've already given it a name?
The project itself?
Yeah.
I have not tried to rename a project, but you can always export it and then import it back again using a different name. You can change the file name because it just picks up the name from the file name. So I know that approach has to work for sure. So let's go ahead and see if we can do anything with it. Okay, so I'm just going to try the rename first. So test canvas, go to here, and it doesn't have a rename option. If I right click here, it doesn't do a single thing. So one thing you can do is to go to project and get an export and then import it back in again.
Or you can always save project as and just delete the original copy. That works.
Oh, okay.
You have to open the project.
So once you open the project, you can go to project, save project as. Okay, so that changes the name also. Yep.
Okay.
And then you just delete the original copy if you want.
Okay. So this saves project as creates a new project under the new name, but it doesn't do anything with the old project. Okay. Go ahead.
I have actually exported it as .aia and renamed the .aia file and imported it, and that does
Yes, that will work as well, because it picks up the name from the name of the AIA
But
file.
unless you accidentally contrast it with the existing project,
Yep.
that works.
So did you get the both ideas? I'll just go ahead and do it once here. So if you want to test, save as, it will use the default of underscore copy, but you can change it right here. And assuming you don't change it, you go back to your project screen. Oops, come on, project, my projects. So now we have a new project under the new name. But you can also do the export and then import it back in again. But before you import it back in again, go to your local file system and change the name of the file. So if you want to call your new project, let's say project 2, then save it as project2.aia on your computer, and then you import it back again, then it will pick up the name of the file and then it will name it as project 2.
Okay.
So those are the two ways that can kind of get around this problem. It doesn't have a under project doesn't have a rename option, unfortunately.
And then my other question was, I accidentally deleted a bunch of code on something I was working on.
Oh.
Yeah, is there an undo or a way to?
None that I know of, unfortunately. None that I know of. I think it has a feature where you can save like a part of the project. You know, I think a checkpoint allows you to save the project as a checkpoint.
Okay.
So that gives you a, you know, like kind of like a somewhat of a backup
Yeah.
to the project, because each checkpoint is kind of independent from the other ones.
Okay.
Yep.
Luckily, I had taken pictures with my phone
Oh.
before I ended up deleting.
Oh, but
it.
that still hurts though.
Yeah.
It still hurts a little bit. Yep. Yeah, you can also, you know, use your own computer to back it up. Just export it, you know, from time to time. Save it on your own local hard drive. And if that's not enough, you send an email to yourself, you know, and send it as an attachment. So now it's sitting on the email server.
Yeah.
You can use the apps.losreals.edu account, you know, because that's basically a Google account, and I think, you know, you probably have a pretty large capacity, you know, before it fills up. Does anyone know how much stuff you
They
can?
give you the standard
20 gigs.
15 gigabytes.
15 gigabytes.
That,
That's
Google
plenty.
gives you.
That's plenty for
Times.
most of your classes. Yep. All right.
Especially when you save everything to all your documents as a Google Doc instead of the, whatever the native is.
Yep.
Really makes it.
That would certainly help. All right. So what we'll do today is to look at the canvas and the sprite again, but this time we're going to do something even more interesting. We're going to include or integrate the concept of a list as in the process of doing this. Okay. So what I'm going to do is I'm going to write an app here that will track the motion of my finger, but instead of drawing what I just drew on the screen like right away, it will have a time delay effect. It will wait until I'm done with the entire drawing, and then it will show me, you know, where, you know, what I just, where I just touched it, and it will draw the pattern, you know, accordingly. So there's a delay effect to the whole thing. That's what we're gonna do today. And then before we start that, we have to get started with the emulator. Right. So we'll go ahead and start a new project. We'll call this one Tracker. Okay, we'll just call it Tracker here. And Tracker is going to have a single canvas to do, you know, just everything, and a little basic sprite, you know, to kind of indicate the drawing of the whole thing. So we'll go to drawing and animation, drag and drop a canvas over here, change its properties so that it displays properly. So for width, we'll go for fill parent, and then for height, we'll go for a particular number of pixels. Let's say, you know, 300 pixels, which should usually look about right. Okay, it's not exactly a square, but it's close enough as a square. All right, and we'll go ahead and drag a ball sprite here. You know, nothing too fancy, and we'll make that ball maybe a little bit larger. Okay, so we'll make a radius of 10 instead of the default 5, and that's my basic application. Okay, that's how I set up the objects. So everything that we have to do now is based on, you know, this particular setup. And what we want to do, yep,
You
go
said
ahead.
300 pixels?
Sorry?
300 pixels for the height?
Yeah, 300 pixels for the height. So what we're going to do is, you know, we want to make the canvas sensitive to a drag event. So this way, you know, when I drag the sprite around, it knows, you know, that I'm dragging the sprite along. Okay, so that's what the first thing we will do is to do that. So we switch to blocks, and we'll go to ball and figure out the ball has its own drag event here. So we are not using the drag event of the canvas, but the sprite. Okay, because, you know, we want the user to start with, you know, the ball in the way it is at that point. We also will need to know, you know, what is touchdown, because touchdown, you know, will give me the coordinate of where it is touched, and then drag will, well, I suppose drag will handle the rest as well. It's just that, you know, the first point, you know, is also reported by touchdown, so we'll also use that. Okay. Now the first thing we want to do is to say, okay, how do we know this application is working? So we'll go ahead and do something that we did before in the previous class, which is basically just to draw the coordinate where the touch point is. So we'll go back to canvas, because only a canvas can draw text. So now we'll select call canvas draw text. Oh, I forgot to drag the element first. Okay. Go back to touch down and put this one over here. And all we're going to do is to draw the text, x, y, the coordinate of x and y will be used here. So get x, we'll go to the x here. Get y, we'll go to the y here. And the text is just going to be the actual coordinate. So this part is the same as what we did last time. We'll use a join operation and make it 3 components instead of the default 2. And of the 3 components, the first one is going to be the number x, the third one is going to be the number y, and then the one in the middle is just a comma as a separator. So we'll put a comma in between, just like that. Okay. This is the touchdown event, which means the first time I touch the sprite, this will trigger. But this is not the drag event. I'll replicate this block to put it into the drag event as well, but I want to test this one first. So at this time, I can start up my emulator and just give it a try. Right. Are there any questions, since we're just waiting for the emulator to start up, are there any questions about all the topics that we have talked about so far? Questions? All right. Row sheet and there we go. So here's my sprite. If I touch on any other point on the screen, nothing happens. But on the other hand, if I touch on the sprite itself, it reports where I touched it. Now you can touch anywhere within the sprite. If this is a big sprite, you can touch anywhere within the sprite, and it will still respond to the touch event because it knows the dimension of the sprite itself. But at this point, any drag is not going to do anything because I have not coded the program to respond to a drag event. Okay, so the next thing we want to do is to handle the drag event off the sprite, not off the canvas. So we go back to ball here, and then we just add our drag event handler, and I'll just go ahead and be lazy and replicate this block here. But when I replicated this block, you can see that we do have some errors here because we don't have y anymore. We have start x, start y, previous x, previous y, current x, and current y. So current x and current y is what we need. So we can go ahead and kind of toss these guys away because they're not useful in this context. We have to use current x, which is the x coordinate of where the touch point is during the drag, and current y, and then current x again, go here, current y again, go here. So now my app is pretty much done as far as testing whether I can drag the sprite along. So we'll go ahead and switch back to here, and you can see that it's the sprite itself is not getting dragged along, but the motion is. So it is still reporting as if I'm dragging the sprite, even though the sprite itself is not moving. Are we doing okay so far with that concept? As long as you start the touch with the sprite and not let go of your finger, it will still register as a drag event for the sprite, even though the sprite itself is not moving. Is that okay? All right. So now that this part is working, the next part is pretty simple. I want the ball to go wherever I'm touching it. Now to make the ball or the sprite to go wherever you're touching it, you just go to ball here and you look into what you can do with the ball and just say move, right? All you have to do is to move the sprite, in this case it's just a ball, to the current X and the current Y location while you are dragging the ball. So now instead of displaying the text, this part is not useful anymore, and I'm just gonna take out that part. I don't want to delete it just yet, so I'm just gonna take it out of the
Right click and disable. Right click it and disable.
Oh, you can disable it too. Yeah. Oh, that's interesting. You can comment out basically.
Yeah.
But in this case, I also want to move the ball. Well, in this case, I don't need to move the ball because I start with that location, so the ball has to be there already. So let's go ahead and test this application again. Oh, I need to clear the screen. So to clear the screen without a button, what I'm going to do is to say if I touch anywhere other than the sprite itself, it'll clear the screen. Okay, that's just one quick and easy way to say, oh, how do we clear the screen? Well, go to the canvas here and go to the canvas and look into its own event handler and say touched. Need to find a good place to put it. And I'm just going to be a little bit lazy by not detecting whether I'm touching a sprite or not. Okay, because if I'm not touching a sprite, this will not be set. It will just be a uninitialized kind of variable. So we'll just go ahead. We'll just go ahead and clear the canvas whenever I touch the canvas itself. So we go to call canvas.clear right there. Now we have an application that has a way to reset the screen itself. So we'll click anywhere on the screen, and you can see that I can now drag the sprite anywhere I want it to go, but it doesn't really do anything with it. But I know the software already knows. It knows where I have been dragging it along. Okay, all the coordinates, can be saved, on in a list. Are there any questions about this app at this point? Now, did you guys see how I debugged the program or test the program really step by step? Okay, I confirmed that the drag event is in fact being handled, it's being triggered. I verified that the numbers are being displayed on the screen. Okay, so I have the X and the Y coordinate of every point that I touch during the drag event. I confirmed that I can drag the ball around. So now I can try to save all the coordinates. In other words, as I drag the sprite along, I'm not going to draw the line along right away. What I want to do is to save all of that coordinate and then do it later on. Okay, so it's a delay effect. Okay, and I can do some processing with those numbers later on if I want to. All right. So to save the coordinate, you might think, well, how are we going to do something like that? Because a variable can only store a single integer, and there's no telling how many points I need to save when I'm doing something like this. Maybe the drag event or maybe the drag session only has 200 points. Maybe it has 400 points. There's no telling how many points there are when I'm doing something like this. The one thing that is really useful for something like this is the concept of a list. Okay? Because the number of items inside the list is limited only by how much memory is available to the application, which in general is a lot. Okay, so for the most part, we can use a list to remember all those points, and then later on we can decide what to do with the points. And with a list, we have to make this a global variable, because otherwise I cannot have the two event handlers or multiple event handlers to share the same, to understand the list. So I can either store into TinyDB, which is not a good idea because you don't want to have to write to a TinyDB, all the time. So we'll make it a global variable. We'll make the list a global variable. So we go to variables here, and say we initialize a global name to an empty list. Okay, so we'll initialize my global variable. We'll just call that points, okay, to an empty list. So we go to lists here, and we say make an empty list. And there are several ways to make an empty list. You can just say, you can drag and drop empty list, or you can just remove the items in the list to make it an empty list. This is okay, but we also want to have a second way to initialize it. So we'll go to the same point where we clear the screen, which is when the canvas itself is touched. And we'll also do an initialization here. We'll go to variables, and we say set global points is the global variable points to an empty list. So we'll do exactly the same thing here. The reason why I'm doing this is because initialize global points to empty list is only done once when the screen starts. Okay, when you're debugging it, it doesn't get triggered. Okay, so you don't get to reinitialize everything when you're touching it. The other thing we can also do, is to do the initialization in the touchdown event, because that's the starting point of everything. So that also is a very good point, or very good place to put this block. So I'm going to duplicate this block and stash it right here. Okay, and this block I can now disable. So I'll go ahead and disable this part here. Disable block. But over here, instead of making this an empty list, I can make it a list of one single point. Because guess what? This is the starting point of everything. Okay, so it makes sense to make to remember a single point in the touchdown event handle. So now I create instead of creating an empty list, I create a single item. But the point has two numbers, right? Because a point has an x coordinate and also a y coordinate. Well, what do you think I can do about that here? Well, we'll make that item a list itself. Okay. So instead of making a list of a single number, the item that I'm creating with the list is by itself also a list. So I can make a list and use it in a nested fashion. It's just like you create a folder inside a folder. So in this case, the outer one is creating a folder, but inside that subfolder, inside that folder I have a subfolder, and then inside the subfolder I have two numbers, two files. Okay. Because remember, a list is kind of like a folder. It is a container. You can have any number of items inside a container. And at this point, I can choose the coordinate of the touchdown event itself, which is x and y, and stash it there. So the touchdown event is now done. It is going to remember where I start with the entire thing. And then with the drag event, I'm going to do something similar, but I don't want to set the global variable to this list anymore. I just want to append to the list. I want to add some more points to the list. If you want to add something to the list, you can go to lists here and select add items to list. Okay, this is the quickest and easiest way to add certain items to a list. So we'll put it here. The list that we're dealing with is our global variable. So you go back to variable here and you say get my global variable points. Okay, this is the list that I want to append something to it. The item that I'm appending is by itself also a list, because remember, I want to append the coordinates of a single point, and one coordinate has 2 points. And in this case, I want to use current x and current y to make that coordinate, turn it into a small list, and then add that small list item as an item to the long list. So this way, I'm now remembering all the points of the drag event. And it's complaining because this one is now out of context. We'll just go ahead and delete it. We don't need it anymore. So we'll delete this guy. No more warnings. Very good. Switch back to the emulator. Touch the rest of the screen to reset the screen. And you can see that, hey, it's not doing a single thing. Well, it's doing a lot of things. It's just that it's not visible. Okay, we are creating a list, but the list is not visible in this application. Okay, it's just a data structure that is maintained in memory. Are there any questions about this application at this point? What if I want to kind of visualize, what is in that list? What is the quickest and easiest way to visualize a list? Kind of talked about it, the other day. Is there a particular element or a particular component that we can use in the designer so that we can quickly and easily visualize what is the content of a list? Go to user interface, and you can either use a list picker or a list view, to kind of visualize, a list. A list picker doesn't take up as much space by default, so we'll just kind of stash it over here, and over on the other side, going back to the blocks here, we'll go to a list picker, and we'll take a look at what we can do with the list picker. In this case, all we want to do is just to see, okay, what kind of points have I remembered? What kind of coordinates have I remembered? And you can see something that's kind of interesting, especially the first two, before picking and after picking, or I should say after picking and before picking, because it's alphabetically ordered. But before picking means if you click on a list picker, that will trigger before picking, okay? Before it displays the content of the list picker when you click it. So it gives you a single event to initialize the list that is associated with the list picker. If you hover over this particular event handler, it will explain that as well. Simple event to raise when the component is clicked, but before the picker activity is started. Okay, so that's a good point to say, oh, okay, we want to associate our global variable points with this particular list picker at this point. So that's exactly what we'll do, but before that, I'm going to have to kind of position everything so that I have a place to put it. This is one part about graphical programming that I really do not like, is there's no easy way to make room for something. Okay, so you have to kind of drag things around a lot if you're making changes to your program. There's a feature in App Inventor called arrange blocks horizontally, vertically, or sort blocks by category. I try not to use that feature, because if you use that feature, it will do its thing to rearrange everything, but it will do it in somewhat of a random way. So the blocks won't be overlapping anymore, but it will be much harder to find your stuff because it just decides, oh, I think this should go over here. It's like, no, I don't want to go somewhere else. All right, so we'll go ahead, we now have room to put it, so we'll go ahead and put sorry?
Musical blocks. Instead of musical chairs.
Oh, musical chairs, yeah. It's kind of like that, it's really, really not, it doesn't try to preserve the ordering of all the blocks that you have already set up and just beautify it, right? Just make it more square and have some space in between the blocks. It just says, okay, let me rearrange everything. I'll move everything around a little bit to make it fit. No thanks. Okay, so list picker, when list picker 1 dot before picking, so we're going to associate our global variable here, and then we go to list picker 1 again, and go through all the methods that you can go through. All we really want to do is to set the elements to our list, the global variable. Okay, I'm just double checking, make sure that is the correct one, and it is. Okay, so we're going to set the elements to a particular list, and that list is just our global variable. So we go to variables here and pick a get block here, and then select our global variable points. I'm not going to specify what to do after picking, because the whole point of the list picker is just to visualize what is in the list. I'm not really there to select a particular point. Okay, so this is just a quick and easy way to see that, oh yeah, we got all the points. Now we switch back to the emulator, and it should have all the code. Yep, you can see that the list picker is here. And since it is empty at this point, when you click it, it just shows nothing because there's nothing in the list at this point. So let me go ahead and drag it around a little bit. And now we trigger the list picker again. And you can see now it has all the points. So it's just a quick and easy way to verify that, yeah, we got all the points. Are there any questions at this point? No questions? This is all good? All right. So now that we have all the points remembered in the list, even though it's not displayed, let's go ahead and figure out the logic to do something that's fun. I want to have a delay effect here. In other words, after I drag the sprite around a little bit, I want to wait 2 seconds after the last event before the program will go ahead and basically slowly redraw everything according to how I touched, how I drag the sprite around. Okay, so how do we create that time effect? 2 seconds. I'm gonna wait 2 seconds.
Clock.
We'll have to use the clock component. So let's go ahead and pick the clock component first. And then after we pick the clock component, what do we do? Let's see, where is the clock component? Sensors. The clock used to be in the first category. They moved it around a little bit. Okay, so with the clock component, there are several things that you can kind of set or change here. One is timer always fires. We can turn it off. Timer always fires means in this case it will fire every 1,000 milliseconds. 1,000 milliseconds, by the way, is 1 second. So in this case, the timer is always ticking. It's always tick 1 second, 2 seconds, 3 seconds, and so on. That's not really what I'm looking for. Okay, so I'm going to turn off timer always fires. And guess what? I'm going to turn off timer enabled also. Okay, because at this point, before the user has done anything, I really have no use of the timer, until somebody is actually touching something. Okay. And now we switch back to the blocks to try to see, okay, but where do we put any trigger of the timer? Now I can put a timer trigger here in touchdown, but that's not going to make a whole lot of sense because if I start the countdown with touchdown, it's going to time out in 2 seconds, which means from the moment I touch the sprite in the canvas, it will give me 2 seconds until I'm done with the whole thing, and then it will trigger the operation of drawing everything after that. That's not what I want to do. Okay, I want to wait until I lift my finger up from the screen, from the sprite. So I kind of have to capture that event. Now the other thing I can do is to go to drag here and keep resetting the timer. In every single drag event, I would disable the timer and then re-enable the timer. Okay, because in doing that, I'm resetting the timer and say, okay, start counting 2 seconds from here, start counting from 2 seconds from here, and so on. But that's not really the best solution. It might work, but it's not the best solution. The best solution is to go to the sprite, which is ball 1 here, and say, when I let go, do it. Okay? It makes sense, right? Because as long as I'm dragging, touch up is not going to get triggered. Touch down gets triggered as soon as I touch the screen. But as I drag it, touch up is not going to get triggered. When I let go, touch up gets triggered, and that is a good time to say, hey, timer, start counting 2 seconds from here. Okay? So that's exactly what I'll do. Is when touch up happens, I don't really have anything to do with X or Y because the last drag event should have captured this X and Y already. Instead, what I'm going to do is to go to clock here and just say, okay, let's start a counter at this point. Or let's start a timer at this point. So we'll go to set clock1.timer enabled to, let's see, true, the Boolean value. Okay, so we say, okay, let's go ahead and start the timer, and let's be sure that it is exactly 2 seconds. So we go to clock1 here, and then we can say set interval to 2 seconds. set clock 1 timer interval to exactly 2000 milliseconds, because when we specify this number, it is expressed in milliseconds. 1 millisecond is 1,000th of a second, so 2,000 milliseconds is equivalent to 2 seconds. Are we still doing okay with this code here? Right. Well, let's test the application and see whether it works or not. Okay, touch somewhere else, leave the screen, and drag this thing around and count 1 second, 2 seconds. Nothing happens. Well, did I say anything what I should do when the timer expires? No, we haven't specified a single thing with the timer, so obviously nothing is going to happen even though the timer expired. So we have to specify an event handler for the timer, for the clock. When time expires, we have to do something, and that's the only event handler for a clock, is when the timer expires. So we don't want to do anything too fancy. We just want to confirm that yes, we are getting this event, and the easiest way to do it is to go to the canvas and just change the background color. That would be a quick and easy indicator to do it. So we'll go ahead and say set background color. Oh, that's pixel color. Right there. Set canvas 1 background color to, and then we'll go to colors and pick something. Doesn't have to be anything fancy. And we'll just set it to gray. And this time, that should happen. I think that's because it's on all the time. And we have to reset the background color to white in order for us to see that it works. So we have to put this block into the touchdown event handler of the sprite. There we go. So switch back to the application, and
You didn't make it white.
oh, forgot about that. Right here. There we go. Thank you. All right. So we move it around, and it changes color right away. So that means the timer got triggered right away. Timer. Okay, let me see if I can reverse the order of these 2 blocks and see whether that makes any difference. We also want to make sure it does not get triggered repeatedly. So we go back to the designer, go to the properties. It is not always firing, so that's good. Right, so let's see whether that works or not. Yep, 2 seconds. Now this time I want to hold it. Oh. I think the touch up may not be working the way it's supposed to. Looks like it's getting triggered all the time.
Yeah,
So
you let up.
I have not let up. I'm not letting go of the mouse, and yet it is still thinking the touch up event has happened. So touch up is not doing what it's supposed to. When the user stops touching the sprite, lifts finger after a touchdown event, provides the XY coordinate of the touch relative to the upper left of the canvas. Okay, I'm gonna do one more thing. I think I know why it's doing this. I forgot to turn off the timer. Okay, so it is possible that it's because of that it gets getting triggered all the time. So we go to clock 1, and this time we make sure that we disable the timer when we have a touchdown event. So we go to timer enabled, and this time we set it to false. So we make sure that it is turned off when we touch down on the sprite. Okay, so let's do it again. Yep, that's it. Release, wait 2 seconds, and then the background turns color. Okay. Are there any questions about what I've been doing here? No questions? All right. Well, now it's time for the fun part, okay? Now we have to draw everything according to the list. There are several ways to do it. You can either draw it all, when the timer expires and go like that, but that won't be very fun, okay? If I want to draw like one point at a time and make connections, but not doing everything all instantaneously, okay? In other words, I want to animate the drawing process. Then what can I do about that? Now, even though the ball itself is a sprite, okay, let's go back to a sprite and see what we can do with a sprite, okay? With a sprite, it has its own interval, its own heading, and its own speed. In other words, I can program it in so that every 100 milliseconds, it will head to 0 degree, which is east, a particular number of pixels, and that can be a floating point number, which means it doesn't have to be exactly an integer. It can be like 5.2 pixels, and it will handle all the rounding at the same time. So that's one way to do it, but that can only draw a straight line. Okay, it will only plot the sprite in a straight line. It's not even going to draw a trailing line behind it, which is not what I want to do. So in order to draw that accordingly, I'm going to have to use the timer again. Now, you can basically use the same timer because with the timer we can always reprogram the interval and say, okay, now I want to have one timer event every 10 milliseconds to make it really quick. So that way it will draw 100 points per second. Or I can set it to 25 milliseconds, which means it will draw 40 points per second. So that's one way to do it. You can also use a different clock. You can have as many clocks as you want, each one doing a slightly different thing. So in this case, since I really don't have use of this timer anymore, after I let go of the sprite for 2 seconds, I'm going to reuse the same clock. So to reuse the same clock, I'm going to go back to my blocks here. And it gets a little bit tricky because if I reuse the same timer, this particular event now has to figure out, okay, which mode am I in, okay? Am I getting a timeout because the user stopped touching the sprite for 2 seconds? Or am I getting an update? Should I update the screen and go to the next point to draw, okay? If you have two timers, one dedicated to timeout of the touch up, and the other one is dedicated to the timing of drawing the points, then you won't have much of a problem. Okay, so this part is kind of up to you. If you want to do it this way, you're complicating the logic a little bit because the timer has to figure out, okay, which mode am I in? What am I supposed to do when I expire? If you use a new timer, you are increasing the number of components of your program. It's not going to consume a lot of memory, but it is going to use up a little bit more resources. So let me just use the simple approach first. Okay, we'll use a second timer, and when we have two timers, it is probably a good idea to rename the new one as clock. This is the clock for drawing something, so I'm just going to rename it to clock draw. Uh-oh. The emulator needs to be reset. Now we have to wait again. I was able to grade about 15 or so of your homework assignments before it needs to be reset. So every 15 homework assignments I have to reset it once. And that's just the hello per homework assignment. There's a button, it plays the sound.
Well, for that you can set up the macro, because it's all supposed to do the exact same thing.
Oh, to reset the emulator?
One resets, spit out if it's successful. Resets for your next homework assignment. It's going.
Well, the emulator actually has ways for you to actually inject clicking and all the events like that. So for testing, there are ways to automate some of that. All right. get our application back. And timer 2 is basically firing all the time anyway. So we want to go to clock draw and kind of turn it off, because otherwise it's just going to be firing all the time. And we'll change the time interval here, let's say to, well, let's turn it to 15 milliseconds. So it will update 20 times per second, approximately 20 times per second. And now we go back to blocks and say, what are we going to do? How do we get it started? How do we get the whole program to start drawing all the points that it has stored in the list? Well, it's all about this one, right? So we'll go to timer, we'll go to the clock 1 timer event and say, okay, let's go ahead and get clock 2 started. But before that, we also have to get it initialized. There are several ways to keep track of where are we on the list, okay? Because let me just kind of put it here so you can actually visualize, see what the problem is. Okay, so I will have clock draw and its own timer event to be put here. So this way I can, in clock 1 timer, I can start up clock 2, right? So here we can specify clock draw, and we'll enable it here. But before we enable it, we'll make sure that all the settings are done correctly. So we'll set timer interval again, just to be sure, to 50. And then we'll set all the other properties. So this time we do want it to auto fire. So always fires, needs to be set to true. And we want to enable it. Whoops, wrong place. There we go. And then we want to enable it. So we go to clock draw again, and this time we say, let's go ahead and let it go. Enable the timer, set it to true. Alright, so with these 3 blocks here, this one, and this one here, we are initializing clock draw to the interval of 50 milliseconds, make it repeat itself, so every time it fires, it automatically resets the timer for the next event automatically. And we also want to turn it on, enable it, okay? So after that, after 50 milliseconds, after these, the last block is executed here, this block will get triggered every 50 milliseconds or so. Tick, 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 tick. But all by itself, it doesn't know, it has access to the entire list, right? Because the list of points is a global variable. So the event handler of clock draw can handle it, can access it. But it doesn't know which point it is supposed to draw. Okay? Are we supposed to draw the first point, the second point? Which point are we supposed to be drawing? At this point, you have 2 options. One is a destructive option, which means every time we draw something, we take it out of the list. Okay? So the first item off the list is always the next point to draw. That's one way to do it. The second way to do this is to use a second global variable to indicate, okay, what is the index? Okay, which one are we handling at this point? Are we done? Okay, because you can just keep counting it. And the second approach is better because you might want to keep that list around and not destroy it. So we'll use the second approach, which means we now need another global variable. So we'll initialize the second global variable. We'll just call that point counter. Okay. To the initialization doesn't really need to initialize it to any particular number. We'll just put a 0 here. That's because we won't need it until we actually have a timeout event from clock 1. So at the end of clock 1, we'll go ahead and initialize the global variable point counter. So we say set variable point counter to the number of items that we have in the list points. So we go back to list here, and length of list will tell you the number of items in the list. And in this case, the list that we are dealing with is our global variable points. So this way, it gets initialized to the number of points that we need to go through. So every time we get into the timer event of clock draw, we will basically just say, okay, we'll draw a point or draw a line between 2 points and then increment the or decrement. actually the point counter has to be initialized to 1 because we can compare that to the actual number of items. So we'll go ahead and initialize it to 1. So every time we get into timer, we first need to see, okay, have we drawn everything yet? If we have already drawn all the points, it's time to disable this particular timer. It has no use to me anymore. If not, we'll draw a line between the last point to this point, okay, and then we'll increment the counter by 1. So as I said a little bit earlier, the first thing we need to do is to check to see if we have drawn everything. So we need an if then else block here. And if then else block here gives you 2 branches depending on the condition here. If this condition is true, it goes to this block here. If the condition here is false, it goes to the other block. So it's a very useful construct for a lot of things. So the first thing, the condition that we need in order to make that decision is based on a comparison. So a comparison is in a math function. So we'll go to, it's an operator. Oh, there we go. And we are not looking for equal to, we are looking for less than or equal to. So we are basically saying as long as point counter is less than or equal to something, we'll draw another point or draw another line, else we'll stop. So here we have global variables, and we say, let's take a look at point counter, and we have to compare it to something. What do you think this something is? I'm trying to determine, do I still have any more points to draw? And we know that point counter starts with 1. So when do you think it should stop?
The highest index.
Say again?
The highest index.
The highest index minus 1. Because in order to draw a point, I need 2 points, right? So I needed to go only up to the number of items minus 1, because that will draw everything. In other words, if I store 2 points in the list, I only have 1 line to draw. So this is also where this particular interface gets kind of cumbersome. It's doable, it's just cumbersome. Because now we have to specify the length of the list. So you go to lists here, you pick up the length of a list, and the list that we're dealing with is my global variable points and minus 1. So we put a 1 here. Yeah, it's cumbersome. It gets it done, but really kind of unnecessarily long. If it is less than that, then we have a point to draw. Okay, so we'll go ahead and specify which point we are drawing. So we go to canvas 1 and say we want to draw a line. So when you select draw a line from a canvas, it automatically gives you the slots. Okay, what is the x of the first one, what is the y of the first one, and then the x and the y of the second. This is where a local variable can really come in handy, but I'm just going to do it the complicated way first. Then you will start to see, well, maybe we should have used a local variable for this. Okay, so how do I specify the x coordinate of the first point that I want to draw? I am only given 2 things. One is points, which is a global variable. It is a list of points, each point being a list all by itself. I'm also given a second global variable called point counter, which tells me which point is the starting point of this particular line. So now the question that I have for you is, how do I specify the x coordinate of the point that I'm supposed to draw?
Points. You have to use the points, get point, item 1, and then 1 of that list.
Okay, so we have to start with, it's definitely going to be a list operation, right? Because points is a list, and we want to access at least 1 item of that first. Okay, so we'll go ahead and pick 1 item from that list first. Select list item, and which list are we talking about? Now this time we have to be, okay, let me get this out of the context of the block first. Okay, we know that global variable points is important. So we know that at some point we're going to say, use that as a list and give me a particular item, which is at the index. The index is my global variable point counter. So I'm going to just be a little bit lazy and drag and drop this one here. So what is this block doing? What do I have with this block here? I'm getting a particular item from global variable points based on point counter. What is this giving me? Is it giving me a single number, or what is it giving me? It's giving me a list. That list has exactly two numbers. The first of those two numbers is my x coordinate. So that means I need to stack another select list item from this one on top of this one. So we say select list item, and the list is this entire thing. So I'm stacking up these things here, and the first item of that list is the x coordinate. So this time I can go to math and specify just 1, which is the first item, which is the x coordinate. That gives me the x coordinate of the first point to draw for this particular line segment. To specify the y of the same point of the line segment, I can do something like this and change this to a 2, because that will give me the y coordinate. What about the next point? It's going to be about the same thing, except the index to index into points is going to be point counter plus 1, right? So if I'm lazy, I can do something like this and something like that, and then just change point counter to point counter plus 1. So I need to go to math again to specify the add operation. One component of the add operation is this, and then the other component is just the number 1. And I think I can do this.
Yeah.
Just specify 1. Yeah, there we go. It's still cumbersome though. It's still more cumbersome than just typing it. There we go. All right. Okay, let me just kind of zoom out a little bit, just so that we can appreciate, the. Yep.
Is there a way to zoom inside of the AI implementer?
To zoom in, it's the same thing as the browser zoom. So if you do a Control plus, it will zoom into. It will zoom everything. It's not just
right. No, I
where the blocks are.
Is there a way to just like zoom in and out of the viewer itself?
The viewer.
Yeah, it's where the blocks are inside App Inventor itself.
Without changing the browser.
Without changing the browser. Yeah.
Ooh, that I do not know. I don't think so, because the old version had it, but the old version uses it runs App Inventor as a Java applet. This one is using JavaScript to do everything, so it probably doesn't give you the same option. Yep. Okay, so that draws a single line segment, and you can see how kind of redundant certain things are here, and that's why well, maybe we can improve this. Okay, so after we draw that line, we have to add 1 or increment point counter by 1 so that we are ready for the next line segment. So now we have to go to variables again. This time we are changing global variable. Let me just zoom in again. So this time we're changing the global variable point counter to become 1 more than what it is. So we go to math again, we specify the add operation, go back to variables, we get the value of global variable point counter, and then just specify add 1 to it. Once you select a block and you type something, it will automatically go to the first unfilled slot of that block. So when you type 1 and press the enter key, try again, 1 and then press the enter key, it automatically goes to the first unfilled block or empty slot of the block that I have selected.
Or you just duplicate. In this case, you just duplicate from right above it.
Yeah. Could do that too.
We're being lazy.
All right. Okay, what do we do with the else? I mean, there's an else here for a reason. What if point counter is greater than or equal to the number of items in points plus -1. If it's greater than or equal to that, that means I have drawn all the points already. If I have drawn all the points already, I can turn off this timer. There's no need for this timer to be firing anymore. So I go to clock draw here, and then set its properties from enable to disabled. So enabled, timer enabled, now it becomes false, and that should turn it off. Okay. If it's not turned off, the logic will still not do anything because it will basically go to the else branch all the time. But it would be nicer just to turn it off so it doesn't tick in the background. All right, well, let's go ahead and give this a try and see if it works. So touch it somewhere else, and we'll move this around a little bit. Wait 2 seconds, and it keeps redrawing. So one of the timers is still taking all the time, and that's why it's re-triggering the whole thing. Okay, let me just go back to the blocks here, and you tell me what the problem is. Okay, the fact that it is redrawing everything from scratch means it is not this particular timer that is the issue. Because if you think about it, clock draw, it can re-trigger itself all the time, but since global point counter is going to be greater than or equal to the number of items in the list -1, it won't do a single thing. It should not redraw everything. So that means it is the other timer that is causing this to happen, because it has to reset point counter back to 1 to start drawing from the beginning again. So this timer is definitely one of, at least part of the issue. So this timer has to turn itself off. That's the issue, is it's not turning itself off. Is that making any sense? So if we have to basically use, we have to tell clock 1 to turn itself off when its own timer expires. So we go to clock 1, go all the way to the end, and we say, it's time to turn yourself off. We don't need you to turn on all the time anymore. Because otherwise, every 2 seconds, this will take and it will restart the whole draw cycle again and again. Right. So we'll touch it somewhere else. There we go. Now we have the application, doing, well, kind of what it's supposed to. Now, but this time, the interval is fixed. When the line segments are being drawn, that timing is just 15 milliseconds or whatever you want to program your timer to be. What if you want to draw all the points exactly in the same timing as when you drew it earlier? Instead of storing each point as only 2 numbers, which is the x coordinate and the y coordinate, you also store the timestamp. So that way you can reproduce exactly the same timing as when you do this on the screen. Are there any questions about this application? Does anyone want to use this as an authentication mean? Because it is possible.
Apparently Microsoft does.
Huh?
I said apparently Microsoft does.
Oh, Microsoft has a lot of stuff, for authentication. Like facial recognition, which is not very smart because you can just take a picture of somebody and stick it in front of the webcam. It works every time. All right. No questions about this?
Find the code from last time where it was the ball was bouncing around by itself, and combine with this code to have it draw its path when it's done.
Say that again?
Combine the code from last time where the sprite
the
was
bouncing ball
around with this code, so when it's done after a certain amount of time, it sets itself off from bouncing and draws the line.
Oh, okay. You can do that. I can certainly do that. So let me go ahead and save the project. export it. This is test. This is not test campus, it is tracker. So we will select tracker. We can export it here too. Okay. We uncheck this one, check this one, and export the selected project to my computer. Go back to Moodle and then upload it. To try and edit it on first. File. Save. Return. And it's now here. Are there any questions about the application that we have just dealt with? Because even though it is, well, I would call it a fairly simple application, it does combine quite a few things that we have talked about. Okay? Now, if you want to, you can also save the entire list of points into a TinyDB. So this way, the next time the application loads, you can optionally, okay, it is up to your own blocks of code to decide whether to reload all the points, and then you can draw all the points again, next time this application is loaded. So you can basically make it, persistent. Any questions about? Yep.
It's not exactly related, but you brought up a timestamp. Been talking about lists. For my project, I was trying to figure out a way that you could log something like if someone gets on the app and says I ran 3 miles today, you can put the date and the miles and do that every time and then have a list.
Yep. Okay, so that's a great question because we are right here, right? So when you look at a clock, it gives you more than just turning itself on, turning itself off, and how often will the timer expire. Let's kind of go through each one of these blocks here. This one is just changing the clock by adding a certain number of days to an instant. It returns a different time basically. So you provide a time to it, and then you say, okay, what is quote unquote the time representation if I just add like 2 days to it? Okay, so it gives you a different time that is 2 days after the date that you give it in the first place. Okay, so instant is basically the start time, and then the number of days is what you specify to give it, so that it will return the time representation of 2 days after instant. Okay, this one is just adding hours instead of day, adding minutes instead of days, adding months instead of days. Months is interesting because it has to be aware of the calendar. So that's actually pretty helpful because you can just say, okay, repeat this every month, but it will do it on the same day of each month, except for the 29th, right? That one is kind of tricky because you only get it every 4 years or so. It kind of hurts when someone's birthday falls on the 29th of February. It's like, you only get a party every 4 years, and then sometimes you don't even get that. Seconds, weeks, years, so that's kind of handy. You can also extract the day of month from an instant. You can extract a lot of things from it. So the question now is, what is an instant? How do we get an instant back? And we can make an instant from something. from a string in this case. So you can use month, day, and year, and then hour, minute, and second in order to create an instant. You can create an instant from the number of milliseconds since 1970. The first millisecond of 1970, you can specify that it will give you a time instant. But there's a quicker way to do it now. Well, now obviously only refer to the current time, okay? But that's how you get a quote-unquote instant to represent the current time. So for logging purposes, this is what you want to store. Okay? The actual implementation of instant is probably some sort of time unit since 1970. That's how Unix keeps track of time. But as far as your application is concerned, you don't need to do anything about it, because you can, every time you want to display an instant, you can convert it back into the regular time format that is easy to read. So you never really have to deal with the internal representation of time, which is nothing more than just a number.
Oh, what came to mind is the Spaceballs argument right now, when they're looking at the video.
I don't remember that particular one.
I'm sure it's probably up on YouTube.
Okay, there's also system time, the phone's internal time, and now is the instant in time read from the phone's clock. That's kind of confusing. And in your case, if you want to display a time, let me just try to see if we have an easy way format. Okay, there we go. So in order to display it, you can use the format method. It will basically use text to describe the date of an instant. So you can use format date, format time, or format date time, which combines both the date and the time. So it will display as, depending on the setting of your phone, I guess, it will choose to display either the year last or the year first, depending whether it's US or European. So that's the quickest and easiest way to convert an instant back into text that the end user can see and go, oh, okay, so that's what we're referring to. Okay. But what about time zone? I mean, when it converts it back to, the actual end user display, let's say you do the jogging, let's say in Hawaii, okay, which is not using Pacific Standard Time, is it?
No.
I don't think so, because it's too far away, right? Yeah. So let's say the jog or the logging of the event is in Hawaiian time, and then you come back to Sacramento or go to the East Coast, somewhere. So when you look at the time, what do you think it would display? When it converts the instant back to a text of the time, what do you think is going to what it will display?
The time at which it was recorded.
It depends on the phone. So the conversion is based on an internal Android, formatting ability, and that's based on your current time zone. So if your phone can pick up the time zone automatically from your location, and most do, okay, most can use your GPS location to pick up the time, or your cell tower would also tell you what is the local time zone. So your phone, if you are in, let's say, New York City, it will pick up its Eastern Standard Time, okay? So what it would do is to display that time in Eastern Standard Time, because it's sensitive, it knows what time zone it's in. But that time will be equivalent to when the instant was actually recorded. Okay. Any other questions? Anything related to your project that you want to ask? Like that one, that's a really good question. It's the perfect timing for that too. Nothing? Nothing?
Not yet.
Not yet. Okay, what about this? What about this question? I want to see how much time has passed between two log events. Okay, how do I display that? How do I know how many days, how many months, how many weeks have passed between two instances? So I use now to record one, and then I use now later on to record the second instant of time. So how do I do some calculation and find out how much time has passed? Yep, it's right there. Okay, milliseconds between instants. Now, once you have the milliseconds, you can choose how to display it, right? Because there are 1,000 milliseconds to a second, 60 seconds to a minute, and so on. So you can do your own math to display it in seconds, minutes, hours, and days. Weeks is okay because there are 168 hours in a week, but months is kind of tricky because it depends on which month you're talking about. Right. Any other questions? How do you make an alarm clock? It's not a good idea to use App Inventor for an alarm clock because it cannot run in the background. But if you don't mind running the App Inventor app, in the foreground, how do you make an alarm clock? And I don't need you to display the current time. I just need it to beep and do the meow thing when it's time. And trust me, when I hear the meow thing, I wake up because my cat has a tendency to wake me up effectively because they need to be fed. They would bite my chin, they would.
Whatever the user inputs and converts it to
milliseconds
from
the current time, and then just set up time.
To set a clock to go off at a trigger when at a certain time.
Yep. What if you have several alarm times that you have to track? You can use a list. Yep, you can use a list so that each one will trigger the next one and then trigger the next one. It gets a little bit tricky afterwards because what if you change one of the alarm time to before another one? Then you have to reorder things a little bit. Any other questions? Okay, if there are no questions, I will finish the archery homework assignment tonight. I will post it, but we won't get started on it until Wednesday because I want to talk about it first before you guys get started with it. Okay, but this is a good sample program to look at. The program that I just finished. I think personally, what is even more important is how I debug the program. Okay, you notice that I didn't write the program right the first time. There were a few bugs as I wrote the program. The question is, how do you diagnose your program and say, okay, this is the behavior. Why is it doing this? How do I go about figuring out why the program is not behaving the way it's supposed to? Okay. Trace it, yeah, but not really easily with this one. Yep.
Small question.
Yep, go ahead.
You want to document within the blocks design,
You can do that.
Like what you do in programming, where you're like, obviously each one of those is a module. What that module is doing. How would you do that?
I would do something like
Just
this,
add
just
comment?
add comment. And you can add comment to each and every block. So in this case, even though I have a block containing a block containing a block containing another block, each one can have its own comment. Now, if you display all the comments, obviously that can be a little bit confusing. But you can turn on and turn off the comments and say, I want to look at the comments of this block. The other way to make this block, or make a program easier to read, is to say collapse this entire block. In other words, you already know this block is working the way it's supposed to, and you're trying to focus on some other parts of this program, of this block. You can just collapse the whole thing. It will give you a symbol like this one here, the squiggly line. That tells you this block has been collapsed. There's more detail to it, but at this time you're not focusing on that block, and so you can hide it. So when you're done with that, you can basically say expand block, and it will display all the details again. Yep, it's kind of nifty.
It's nice.
Sorry?
It's really nice when you're working with a larger program.
Yeah, well, especially with the graphical design, because you can't really just say, okay, insert new lines here and push everything down. Yep.
As far as grades are concerned, it seems to me like you kind of expect us to at least incorporate everything that we learned into our project to get an A on it, correct?
Well, there are some core features that I need you guys to incorporate into your project to get an A.
Can you
outline
Maybe
that.
over time specify that?
Well, over time, I will kind of give you guys an idea of what needs to be incorporated. Yep. Thank you for the reminder. All right. Well, we are done here. I'll see you guys on Wednesday. But start thinking about your projects. How these features can be incorporated into your project.